Exponentiation of the function
equals
s
to
cube
3.141572.
check
Riemann integral of this function
s cube x.
Alright guys, welcome back to this channel, and in this video I'm going to be solving this question. We have to show that 1 plus cos theta plus 2 cos theta plus dot 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 into the nth of the cos theta is equals to 1 over 2 plus sine of the absolute value n plus half theta over sine theta over 2. So basically what we want to do is to show that the left hand side is equal to the right hand side. So we'll do that in a bit. And if you are just new to this channel, I want you to just click the subscribe button, because videos like this will be dropping subsequently, so you won't miss all of these videos. So just click on the subscribe button and get to enjoy every of the videos that we have on this channel. So let's get right into what we have on the screen. So I want to show this guy, right? So basically, from my result here, so we want to approach this from a standpoint of complex analysis, right? From the point here, it denotes that this is the real part, because I can't find I, right? I can't find I here. It's the real part, unlike the imaginary part that has I. Remember that a complex number z is of the form x plus iy. You remember that this part is the real part and this part is the imaginary part. Do you remember? So since there is no I in all of this answer, so we want to focus on the real part. Okay, so having known all these facts, so let's get into solving the question. So first of all, I can write this in a complex form, right? We know that I have, let's say, solution, right? So I have 1 plus cos of theta plus cos 2 theta plus dot 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 plus cos n theta, right? Now this also means that the real part of 1 plus cos theta plus I sine theta. Exactly, because this is also like just picking the real part of this particular point, plus cos 2 theta, right, plus I sine 2 theta. That's clear, right? Then on and on to cos n theta plus I sine what? N theta. But we're just considering the real part. So looking at this quickly, remember that we can write real number, complex number in 3 forms. We can write it in Cartesian form, which is z equals to x plus iy. We can write it in polar form, which is r cos theta, right? We can write it in this form, and we can also write it in exponential form, right? Something like this. All right, so we want to decide that in this particular question we will be doing it in exponential form. So I want to write this guy here in exponential form. Do you understand? So that means that I would have, in the absence of the r, that means our r here will be 1. So my real part for this question will be 1 plus e raised to power I theta. Exactly. Then plus e raised to power 2I theta. Then on and on to 3 raised to power what? Ni theta. Do you understand? Ni theta, because I'm going to the nth there, right? So from here, then I can see that there is a pattern, right? This is like a series, because there is a growth process from 1i to 2i. And then if I should expand this, if I should write this more and more, let me say I want to write it more and more. Let me say I want to write it more and more. I will have something like this. I will have plus 2 3i theta, new graph, then plus 4i theta, then like that. You get so it means that there's a growth process, and since there's a growth process, it means that it's a series. But guess what? This particular series is starting from zero when your n is zero, right? Which means that this is of course your e summation of all these ones starting from zero. Now we have to first of all correct the particular notion. Remember that the sum of series, right? We know that it is a into r raised to the power n minus 1 then r minus 1, right? That's if our r is greater than 1, you remember. But this particular series here is actually talking about a series whose k is starting from 1. Suppose we have summation of I starting from 1 of, let's say, cos of maybe k theta. Let's say this one is k. It means that I'll start from cos theta, cos 2 theta because it's starting from 1. But in a case where it is starting from 0, it's not going to be uh, n raised to power 1. And it's not going to be r raised to power n. Let me just write that. It's not going to be r raised to power 1. So when your series is starting from 0, the correct thing to write basically is xn in this color. Let me pick yellow. It means that xn will be a r raised to power n plus 1 minus 1, right, over r raised to r minus 1, still when r is greater than 1. This will be the correct formula we'll use since our series is starting from 0. Okay, so having known this fact, now mind you, this one here, it is the growth power. What do I mean by growth power? Suppose I have 1 plus r plus r2 plus r3 plus dot 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 rn. It means that the growth power here is just increasing by 0, 1, 2, 3. So the growth power is 1. In this case now, the growth power in this question that we have here, what do you think the growth power is? The growth power is going in the multiple of I theta. Do you get? From I theta to 2I theta, 3I theta. So our growth power is I theta. Exactly. So having established this fact, we'll continue with what we are supposed to do. So then I would have the real parts basically of, so what's my first term? Now my first term is 1, right? That is my a. Then my r, what's r here? Obviously my r is e raised to power I, uh my nth term, right? That's n actually. So n I theta, that's serving as my n here, serving as my n in this person here, right? Plus 1. Now what's my 1? That's the growth power. What's the growth power here? I theta. Do you get? Minus 1. So I've done the up over r minus 1. What's our r now? E raised to power I theta, right? Minus 1. So this is the series we've just formed. All right. So from here we'll proceed, and we can actually uh, condense this question in a more visible way. 1 times anything is actually 1. So this can be written as e raised to power n plus 1, right? N plus 1 I theta, I think. Is that fine? So if I should bring it together, like just factorize it, I'll have that over e raised to power I theta minus 1. So this is what we have now, and this is what we want to work with. Okay, this is what we want to work with. And to work with this, let me introduce a particular um, structure. It's still mathematical based. Right, let me just clear this off so that we can have enough space. Okay, look at this. This is the same thing for me to write that E, sorry, the real part, but I'm still emphasizing on the real part. Emphasizing on the real part that E raised to power n plus 1 I theta right? Minus e raised to power 0. You know that is still 1. Do you agree with me? Okay. Then e raised to power I theta minus e raised to power 0. That's still 1, right? Now, since you agree with me, you also agree with me that normal 1 over 2 plus 1 over 2 is what? Is 1 bar. So since 1 over 2, that is half plus half is 1. That means since this one is a whole number, it's like one of this, I can split it to half of each of them to arrive at my final answer. This is what I'm saying. I can rewrite it like this. The real parts of e raised to power n plus 1 I theta over 2, you get, plus, which is still times in terms of indices, n 1 over n plus 1 I theta over 2. Do you get the gist? Then minus, now, since it's 1, I can write this one as e raised to power n plus 1 I theta times e raised to power minus n plus 1 I theta. Do you graph? Because minus that one will cancel out, become 0. Then that's still 1. I'm still doing the same thing, right? So over e raised to power, I want to split that into 2 also. E raised to power I over 2 times e raised to power I over 2. I theta over 2, I mean. So minus e raised to power I theta over 2 e raised to power, this is not a minus, this times dot e raised to power minus I theta over 2. Do you grab that? So that's where I found myself. Okay, so then I can factorize, right? I can factorize. The real part will now be e. What's common here now? E raised to power n plus 1 I theta, right, over 2 is actually common. Let's bring that out. So we'll be left with what? E raised to power n plus 1 I theta over 2 minus what? E raised to power minus n plus 1 I theta. Is that fine? E raised to power minus. So let me call this one half so you can work with what I want to do. It still works to be 0. So this is over 2. Right? Then I have everything over e raised to power I theta over 2. Then what's common here too? So I'll just add I theta over 2 minus e raised to power minus I theta over 2. Now, so far so good. I'm here. So what do you notice? But before I proceed, let me just quickly do a recap of what I've done. Let's go straight up. I I I said that we are dealing with the real part because there's no I, okay, and we wrote it in terms of complex number where our number can be written in exponential form. And I mentioned the fact that we have three forms of writing complex number, but we chose to write it in exponential form. And when I got to the sum, I was talking about the growth power. And also, I said that when your series is starting from 0, then you rather use r raised to power n plus the growth power, then minus 1. Okay, then you proceed since it's starting from 0. So I will move on and on with that factorization. What we just did there was to split up our single number into halves, and we were able to arrive at what we want to arrive at. Okay, so let's continue with this. So at this point, there's something looking alike. Have you seen it? Okay, let me just show you. So this is real part of e raised to power n plus 1 I theta over 2. Then over e raised to power I theta over 2. That one is standard. Let's just leave down like that. Let's focus on this place. You see that this one is looking like something familiar. It's looking like sine. If you notice, remember that. Let me just clear this pattern, just record it, then I'll just say it at once. Remember, remember that sine theta basically, right? Sine theta is equals to e raised to power I theta minus e raised to power minus I theta, right? Over 2i basically, over 2i. Remember this one. Okay. So this is standard. And you are looking at something. This is I e raised to power I theta, that means n plus 1 over 2, minus the same thing, but having a minus, just like in this form, right? So it means that I can write this as a sine theta. But you might be asking, okay, what about the 2i, right? Definitely it must have cancelled. Let me show you. Let me show you. So if I want to say that real, you have e raised to power n plus 1, right? I theta over 2, that is our own, the factorized part of it, over now I said this is sine, um if I let me just call it 2i, right? 2i, then my theta will be what? N plus 1 I theta over 2. Do you grab the idea now? Then over 2i, then sine what? Sine um sine theta over 2 basically. Sine theta over 2. I won't even need to put my I here. I won't be necessary because it's just sine theta. Let me just take away the I. Sorry about that. So I have this. What do you see now? You see that this guy will cancel out. This cancels out. So I'm left with the whole of this. So my answer here at this point will be, let me just factorize down so I won't have stress of writing it all over again. So that one there, if I should open it, I'll be having something like this: n I theta over 2, abi, plus I theta over 2. Do you grab? Then minus the one below, that is I theta over 2. So that I won't be stressing myself writing it all over again. So I'll just have sine of n plus 1 over 2 theta, then over sine of theta over 2. So it's already looking like what we want to, where we are going to. So this cancels this. So you can get rid of that. And we are at this point. The real part, okay? The real part of e raised to power n I theta over 2, are we together? We'll have sine of n plus 1 over 2 theta, then over sine of theta over 2. Right. So, of course, again, from our complex number, we know that I said it earlier that we want to write it in complex form, that this particular one here, this one here is the same thing as writing z is equals to r cos theta plus I sine theta. I think I wrote it earlier. That is the second one here. So r can cancel r. Then this inner guy is still the same thing as this long one, right? So I can bring the idea here and do exactly the same thing by saying that this is real parts, right, of cos cos n pi n theta, I mean, over 2 plus what? I sine n theta over 2. Is it clear? Then our normal expression sine n plus 1 over 2 theta over sine theta over 2. Don't worry, don't be discouraged, you'll soon be done. Don't be discouraged. So step by step. So you know what we're gonna do now? Um I want to open the brackets so I can now focus on my real part. So the real part, if I should open the bracket, let me open the bracket. That means this guy here times the whole of this bracket, then this guy times the whole of this bracket again. So I'm going to have something like this. I'm going to have cos n theta over 2, right? Then times sine of n plus 1 over 2 theta all over sine of theta over 2. Is that fine? Plus I sine, I'm talking about the second multiplication now. So that's n theta, n theta over 2, then times the whole of sine n plus 1 over 2 theta, then over the sine of theta over 2. So at this point, we know what to focus on and we know what to throw away. Since we are dealing with the real part, so I will just do away with this part because this space is the imaginary part, right? This is the real part. This is the real part. Since there's no I, that's what I mean by a real part. So I'll just focus on that. So I won't need to be writing RR again. So I'll just say that my question, that is the series that we are working with, is actually cos of n theta over 2 sine n plus 1 over 2 theta, right, over sine theta over 2. Now, here we need to remember something. We need to remember our, what's it called? Trigonometrical identity. I would have just gone straight to the answer, but let me just remind you. You remember that sine A minus sine B is equal to what? Yeah, 2 cos A plus B. Remember, then cos what? A minus B over 2. It's clear now. So, and also remember that if this is this, then it implies that cos A plus B over 2 cos A minus B. Oh, sorry, it's not cos A, that's plus instead. Sorry, this will be sine. Sorry about that. This will be sine. This is sine instead. So let me change this onto a sine. Yeah, it should be sine. Yeah. So this from our IFS 114, the normal introduction to mathematics. So B over 2 being a long way. If I should factorize it, that means I'm going to be having something like 1 over 2 into sine A minus sine B. Do you get? I'm just trying to factorize so that it can make sense. It now means that cos of, let me call the whole of this one, let me call it phi. Then cos of, let me call this one, give me one letter, let me call it beta, is equals to 1 over 2 sine A sine phi plus beta minus sine what? Phi minus beta. So this is just our element from your elementary. So now that we know this fact, it means that this is like my cos file. This is like my sine beta. I'll just substitute it and get to where I'm going. Diagram. So I'll have cos I'll have 1 over 2 now instead. I'll have 1 over 2, right? 1 over 2 into the bracket of sine my alpha. My alpha is n pi over 2 plus n plus 1 over 2 pi. So you got then minus sine of, then I'll subtract n pi over 2. Let's clear off. Just put this one at the back of your mind. Let me just clear so there can be space. N pi over 2 minus n+1 pi over 2, right? Now, don't forget we still have all over sine of pi over 2. Don't forget. So what does this look like from the elementary? If I should do the basic expansion here and there, we need to, okay, here I need to clear some spaces. Okay, so if there's any point you want to check in the video, you can just scroll up so I can have enough space. So let me clear this first part so that we can, have space. All right. So let's bring this one up so you can focus on it. Sorry. So we can know what we are doing. Okay, so this is where we stopped. We now have to. All right. Great idea. Good. So since we stopped here, you can also expand so we can, continue from there. So if I have 1 over 2, if I should expand that one now, I will have sine into n pi over 2 plus n pi plus pi over 2 diagram minus sine of n pi over 2 minus n pi plus pi over 2, right? N pi over 2 all over the sine of pi over 2. Are we together? We should be done. It's not hard. It's just actually long. So if I have something like this, let's take it. Let's take it small, small. So if I should do that one, so the LCM is 2. You remember from elementary. Alright, just joking actually. So I'll have my 2n theta plus theta over 2 for that one, right? Then minus sine. Now n theta will cancel n theta, so I'll be having minus theta over 2. You get over sine of theta over 2. And remember from your trigonometry that sine minus theta is equal to what? Minus sine theta. Abi? So since you know this one, it means that this one will translate to be 1 over 2 into, if I should divide both sides again, if I should share the bracket, so we will cancel this and we'll still have this over 2, right? So we can get closer to our answer. So I have sine of n pi plus pi over 2. Now it will now become plus because this minus from this row here, this minus will go to that this minus, then it becomes plus. So plus sine what? You see that you have gotten our answer over sine theta over 2. Then from here, okay. So from here, what do you think we'll do? Just split it. I will have 1 over 2. Let that 2 multiply that one there, so we won't have to waste time. So we'll just say that sine, let me bring out the theta. So I have n plus 1 over 2. Abi, I just brought out the theta. Then plus sine theta over 2. This is over, I'm multiplying that to now sine theta over 2. Abi, over 2 sine theta over 2. Obviously, you're already screaming the answer. So this goes to this. So I have 1 over 2 there. And bam, you have your answer. I have sine of n plus 1 over 2 theta over 2 sine of theta over 2, right? Then plus 1 over 2. And of course, ladies and gentlemen, you can see that we have gotten our answer. Our answer will be what now? 1 over 2. If you were to place it to the required answer, you just have to rearrange 1 over 2 theta over 2 sine of pi over 2. And we are done. Are we not done? All right, guys. That's how to solve this question. You can see that it's actually the same thing with what we asked to show. We asked to show that this, and we have been able to show this, and very simple. So just rewind the video to check every step that we've mentioned and to get clues and clues and understand this proof. And most importantly, don't forget to subscribe because we're still going to be dropping other solutions, especially from the homogeneous part for those exercises. We're still going to be dropping more videos this week and subsequently. So ensure you subscribe. So once the videos drop, you can always get notification. So you can turn up your notification button and you subscribe. And until then, make sure you keep studying, reading, and I wish you best of luck. See you. Bye.